Thank you all very much. We'll just jump right into it. We're really going to be jumping from extremely low in the stack with the last talk with a really awesome homomorphic encryption talk to very, very much higher in the stack, talking about how cryptocurrency users are being targeted, attacker behaviors, and really what in my view is sort of the future of account takeover. First, quick about me. I run security at Coinbase. Talk about what maybe just a quick show of hands, actually, because I'm super curious. Let's start at the very top level. Cryptocurrency. Who's here is familiar with it, has touched it, has played with it? One, two, call a half a dozen, 10 hands. Great. And then, so I'll start real quick background. Coinbase is a cryptocurrency company. So we deal in Bitcoin, Ethereum, Litecoin, et cetera, et cetera, et cetera. Up, better. Got it. I'll eat the mic a little bit more. Apologies. So we deal in cryptocurrencies. We are probably one of the biggest cryptocurrency platforms around. We store, depending on what the price is today. Today it's somewhere around $8 billion US worth of cryptocurrencies for our users globally. أتكلم شوي عربي. أنا سعيد جدا بفرصة ممارسة اللغة العربية هنا. شكرا. So the other way I talk about what I do at Coinbase is because cryptocurrency is sort of internet movable money. I talk about it as we run the world's largest capture the flag, right? Where the flag is $6 billion or $6 to $8 billion of our users' money. This gives us a lot of motivation to protect it, right? And gives attackers a lot of motivation to take it from us, right? So a quick agenda. You learned about me. We're going to talk a little bit, because the audience is a little bit unfamiliar, we're going to talk a little bit about Coinbase and lay some sort of context down so you guys understand. We're going to talk through sort of what we see as common techniques for users targeting cryptocurrency users. And then we're going to roll into some places we see attackers actively innovating in how they are attacking our users' sort of decision cycle, how they're trying to steal cryptocurrency from folks, right? The first piece of context, and this slide, the first piece of context to understand is that cryptocurrency is a heavily targeted industry. So we average cryptocurrency as an industry from a company side averages, I think the number is currently 9 major breaches a year, where the losses are normally counted between tens and hundreds of millions of dollars in each loss. Hugely actively targeted space. However, the losses from cryptocurrency company targeting are actually dwarfed by the losses from individual user targeting, right? And think about it this way: if you're an attacker, would you rather come after me, who has a 40-person security team that's focused on doing nothing but protecting cryptocurrency, or would you rather come after individual user over there who does not have a 40-person security team securing their Gmail account, right? The choice is pretty much intuitively obvious. You go after the user, right? So user losses in this space have been extremely high. And we see attackers, again, because of that money motivation, because in this space, it's not like stealing a credit card or stealing a social media account where you have to go through and then sell it and convert it to value in some way. You have direct access to value. We see attackers really, really focused on this area and innovating very, very heavily. So a bit of more context about that. So we have about 30 million users across the world. We're active in, I lose count. I think the current number is 45 countries around the world. So we have that's interesting because we have users from cultures, all kinds of cultures, all kinds of spaces, all kinds of age groups, a really diverse collection, which makes user protection a really interesting problem for us in particular. So the other thing we do is again, we take account takeovers and user losses very, very seriously, because it is directly correlated to a user staying on platform or not. Right? A user experiences a loss on Coinbase, even if it was entirely on their side, their Gmail account got hacked or whatever, chances are they leave Coinbase, right? So we want to make sure that we build a platform that prevents the loss from happening in the first place, and second is extremely resilient and can stop things sort of in the middle. And then we want to get into the attacker's decision loops and motivate them to go somewhere else, because our attackers are largely economically motivated, right? So I divide up the world of attackers into two buckets: the economically motivated attackers and the economically non-motivated attackers, right? Economically non-motivated, I think of the traditional government attackers. The NSA doesn't care how much money they spend in the attack. They're after the information. The average transnational criminal group, whether it's formal or not, has a profit and loss statement on that attack, right? They want to make money. They don't want to lose money attacking a platform. That means I can effectively defend my users by making it economically infeasible for the attackers to come after me. They're just going to go somewhere else and steal someone else's money, right? Let's see. So again, because of that, we deep dive and we investigate basically every single report of loss on the platform. So we have tons of great data on how our users are actually getting attacked. And that means we also see the edge cases of how attackers are doing new things and innovating. Because again, my job is to stay one step ahead of that, right? So that we are making it harder and harder. Attackers don't want to come at us because their technique's going to get ruined, right? They're going to go after someone else that's slower. Let's talk this. I'm going to talk. I'll mention this stuff briefly at the end as well. I'm largely going to talk about stuff that's actually effective. So you're not going to see me talk about credential stuffing attacks in this talk, because credential stuffing is largely ineffective on our platform because we enforce 2FA for every single user. You don't get an option to have 2FA on Coinbase. You just have it. But we will talk about a bunch of other stuff that attackers are doing. So everyone, this should not be a shocking concept to anyone. Phishing is a thing. It's been a thing for a very, very long time. A lot of people have talked about phishing defense as in, okay, we'll add 2FA and you're fine, or what have you. Attackers are getting extremely smart about this these days. So most phish kits that we see targeting Coinbase actually include a 2FA theft component as well. Right, so that's actually what our login page looked like. So it's not ours. You can't possibly see the URL up there. That's fine. So that's not our login page. It looks just like it. If you enter a username and password there and click through, it'll actually give you a clone of our 2FA prompt as well. So you enter your code from your TOTP. On the back end, what we see for modern phishing apps like this is it is in real time making API requests right back to Coinbase on the back end. There's zero delay between the user entering their username, password, 2FA, and the attacker using that information to get access to a back-end account, right? That stands in stark contrast with historic patterns in this space. Historically, we saw attackers getting a bundle of credentials. It would normally drop to an email address or a text file somewhere. They'd bundle it. They'd use it in 6 months, right? So great. 2FA pass through. That's fairly upcoming, and not a lot of sites are seeing that yet, but they are. What we do though is we also require a device verification a device verification step on login. So this says, okay, we fingerprinted your browser. That's a new browser. We don't know what that is yet. This largely stops phishing in its tracks. And for if anyone's here is running a major or wants one day to run a major internet site, I highly encourage browser verification. We see more and more sites rolling it out now. LinkedIn's doing this now. Half a dozen other major sites are starting to do browser verification for anti-phishing. It's one of the most effective countermeasures I can recommend. However, attackers are innovating here too, right? So we do browser verification. When we fingerprint your browser and say, this is a new device on your account, we'll send you an email and say like, hey, this is new. We don't know this before. Please let us know if this is legit. And then we enforce the email that caused that notification to be sent it's the IP address that caused that notification to be sent is the same IP address that has to click the link to authorize the device. Right, so there's no world where the phisher can cause it over there and convince the user to click the link by themselves. It doesn't work, right? So what do attackers do? This is also an attack page. So this would be the third page that you would see if you were going and getting phished for Coinbase. The first page, username, password. Second page, 2FA code. Third page, it's asking you to copy and paste the link that appeared in that email. Now, what we see is that this is almost completely ineffective, because it pushes users so far out of their comfort zone. so far out of their patterns that most users that would absolutely provide username password, would absolutely provide 2FA code, will not do this, will not actually actively copy and paste. We actually go to user research on this, and we see almost 100%, you know, whatever the actual number is, 90 something percent, will do username password, we'll do 2FA, and something like 5% will do this because it's so foreign for users. But this is just the first cut. Like I haven't seen attackers do this for LinkedIn or any of the other sites that do device verification yet, but they will, and they're going to get better at it, right? This is why I say I think for the most part we're seeing the future, the sort of the cutting edge of attackers as they try to break into online accounts, right? But so let's see. I'll hop into so when we look at compromise via phishing and account theft that way, we see an extremely low success rate for users, right? Well under 1% on our platform. The way users are actually losing their crypto today, and this isn't just Coinbase, this is across cryptocurrency, and I would argue across platforms in general, the way attackers are losing control of their accounts today is social engineering, is more traditional social engineering, right? It comes in about 100 different forms, everything from stuff on Twitter. There's some nice examples of Twitter scams, a couple of nice examples of the Twitter scams there. Impersonations, we see it on not just Twitter, we see it on Instagram, we see it on Facebook, we see it on everything else. But the interesting thing is diving into like what actually happens below or under the hood a little bit, right? So in general, what these guys are doing is they're doing one of two things when they socially engineer users. They're either doing something called advanced fee fraud, which is a thing that's been around since money, basically, that says, hey, I'm going to do this awesome thing for you if you're just going to give me some money up front. And then the fraudster takes the money and runs, right? It's advanced fee fraud. So they're doing that, and that's very common. You know, hey, send me some cryptocurrency here, and I'll double your money. Turns out money isn't free, so that's almost never is a true thing. The other path, the other way that they're compromising accounts via social media, social engineering, which is a very unwieldy phrase, is by impersonating either sort of support centers, right? So we've seen this historically with like Microsoft or other OS level accounts, cold calls coming in saying, oh, hey, this is the Microsoft Security Support Center. You have a virus. Please pay me $59 to clear it, right? That's been around for forever. What we haven't seen a ton of in the past is instead of this pay me $59 to clean your computer thing, is them leveraging that to access online accounts, right? So we see this more in an increasing pace for Coinbase accounts, and we see it actually for other platforms as well, where it goes away from I'm a Microsoft security support rep and you have a virus or whatever, to oh hey, I'm gonna tweet out Microsoft support, or pick a fake Twitter name that sounds sort of like that, and lure users to call me directly by putting out sort of fake phone numbers, right? This is actually one iteration of one theme that we'll see as we talk about sort of what attackers are doing to do this differently, is they're moving in a direction that is attempting to poison the information that users are using to make decisions, right? We'll see this when we talk about Google answer box poisoning and Google Maps poisoning. It's actually pretty cool stuff. But the broad theme of going away from directly scamming via outbound calls and into a world where they're attacking the knowledge bases that users are using to make good decisions is a very insidious sort of attack path on users' ability to effectively exist online and protect their accounts. So the way this looks like for Coinbase and for social media is you call this whatever support center you're going to call. They say, hey, do you have problems? Yes, I do. Great, I can help you with that problem. Please install TeamViewer or go to my PC or PC Anywhere or pick a remote desktop application and say, great, I need you to install that in order to insert sort of FUD here. It might be in order to fix your Bitcoins or whatever. They'll use that. They'll say, hey, user, go and log in for me. They'll log in. They'll send the screen frequently goes black. They'll send their coins offsite, and they'll come back and say, oh, we're done, and hang up. We know this because we go and get scammed all the time. I have a whole team that does nothing but go and get scammed. They're great at it. It's really, it's wonderful. They've gotten scammed probably, I don't know, half a dozen ways in the last week or so. So how do you fix that? The number one thing that we found is effective is, and this is not by any means 100% defense, but is more effective browser profiling on the website. So the number one thing that we do, that's the hardest thing for the attackers to change here, is the behavior of the mouse on remote desktop systems acts very differently than on a native system, right? If you map the mouse path, you see that there's a lot more jumpiness. There's a lot more space between the points that it passes through on remote desktop instances versus on non-remote desktop. So we profile that user activity. We don't do full user profiling in terms of typing and mouse movement and all that stuff, because we've played with it and it just isn't effective enough yet. But we can do that this sort of feature-based remote desktop sessions act this way and other ones don't evaluation, and that we've seen is extremely useful in separating sort of the sheeps from the wolves in this context. And then what we do when we see that is we don't, and this is a general approach that we take, we don't like lock the user's account because that would be terrible. We'll just pop up very, very loud warnings on the site, right? So you log in with the remote desktop where we think it's unusual, and we'll be very upfront about like, hey, if you're on the phone with somebody right now, it's a scam. Don't do it. And that has made a significant difference in user behavior as we've tested it, versus the just locking accounts of people, where that's just another obstacle the scammer will overcome, right? The account's locked up. Yep. Sorry, we had an issue on the back end. Just go ahead and log in for me again, and we'll get it resolved, and they'll send their money anyway. But if we sort of take a page from the scammer's game and inject information into that user's decision cycle and say, this is a scam, stop, we see users actually pay attention and change their behavior, which is pretty interesting. We do a bunch of A/B testing on this stuff as well to sort of better target our mitigations to a place where we're actually forcing user behavior change, which is a lot of fun. So this is one of my favorite topics as we see it becoming more and more mainstream. So this is phone porting and SIM swapping. This is a problem only in a select number of countries. So it's a huge problem in the US. It can be a problem in Australia and a few other countries that have phone number portability laws, right? Where you're allowed to move phone numbers between carriers very, very easily. It can be SIM swapping can be a problem globally, potentially, depending on your phone carriers and how they do security. So the concept here is, on a phone porting attack, you have a phone number, I want your phone number, I call your carrier and pretend to be you using some very publicly available information and say, yep, I actually want to port my phone number from Verizon to somewhere else, AT&T, right? Great, now I control your phone number. So if you're using SMS two-factor authentication, that's going to be a problem for you. Even if you're not using SMS two-factor authentication, what we found is most sites on the internet, if you go through their account recovery flows, they essentially devolve to SMS for 2FA, right? Which is terrifying, right? So we see that the very, very common attack chain we see here is attacker gains control of user's phone number. Attacker will go through the account recovery path for whatever that user's email address is, Google, Yahoo, whatever, which essentially will back them off all the way down to SMS 2FA. They'll do that, they'll get in, they'll then ransack that user's personal files and email address and everything else for information that leads them on to a Coinbase or a Gemini or a Fidelity or Wells Fargo or wherever they actually want to get to. More often than not, what we're finding is that users are storing things like 2FA backups, backup codes, other things like that in their draft folders. Right. So when we've gone through and worked with users to go investigate, well, let's look at this attack chain, we see attacker searches tailored to those exact things as soon as they get into email accounts. Right. What this tells me is we're looking at a world and saying, we have 2FA, this is wonderful. We don't, by and large, actually. We have 1FA, and it's an email account. If you have access to that, in general, you have access to everything else in that user's life. Period. Which is what makes this the most damaging attack. So SIM swapping, I'll talk about real quick. So phone porting going between companies, AT&T to Verizon or whatever. SIM swapping, it stays in the same company, which actually makes it much harder to detect. You just call Verizon and say, oh, I have a new handset, I have a new phone. I need you to swap my phone number over to my new phone for me, please. You go through some verification, which is again almost always public information, or basically public information at this point in the world, and they go ahead and do it for you, and then suddenly you, as the user, as the consumer, lose access to your device. It literally, what it looks like from the user's perspective, is you look at your device 1 minute, you're good. You look at the device next, you have no signal, no bars, and you don't know why, and you have to call the phone company, who's very, very confused because you just closed your account with them, or you were just on the phone with them to tell them to do something else, right? So from a user's perspective, it's incredibly hard to even know what went wrong there. By the time they figure it out, the attacker's already 6 steps ahead of them, and probably in their email account and on to their next leg of whatever their exploitation chain is, right? So what do you do about this? There's a couple of things. The telecom ecosystem, I guess if I put it mildly, is opaque. There are the best ways we found of dealing with this are finding companies that have data sharing agreements with the telecoms to say, tell me the status of this number. Has it been ported recently? Has it been moved? Has it been SIM swapped? And doing real-time checks on users' phones when they're performing actions with those phones. If you get an SMS 2FA prompt, and we will at the same time check the status of your phone number to say, has this phone number been ported recently? And if the answer is yes, we won't honor that 2FA code. We'll say, hey, we think you ported your phone number recently, and then we'll push you to an account recovery flow if you want access sooner, or we'll just inject a 24-hour delay and say, just come back in a day, and you'll be fine. We find that delay injection injects a little bit of friction for the user, but it injects an enormous amount of friction for the attacker, who wants to be in and out well before that delay expires. That's the other thing we do a lot of when we protect our users at Coinbase is delay injection. We'll give the users a happy path to short circuit the delay. Normally it's with an ID verification, or it's some other more in-depth authentication mechanism, and to say we're gonna delay this transaction 48 hours. If it's legit, you want it faster, great. Just go through this path over here. That for a user should be relatively easy, and for an attacker is shown to be extremely hard, right? And that's been, I think, an extremely effective way of, again, changing users' behavior in a way that doesn't change it away from using the platform, right? I think we've seen this in phishing in general in security, but it is amazing the degree to which users will go to get themselves scammed, right? Or to get themselves phished, or to get themselves compromised. So we never want to be in a place, or we also want to be in a place where we're more subtly adjusting their expectations as opposed to directly opposing them, right? It has much more effective outcomes for users in general. Two more things. So we talked a little bit about telephone scams already. Search engine poisoning gets more toward some of the topics that we talked about up front. A quick time check. Gets more of the topics we talked about up front, where where attackers are starting to poison the repositories of information that users use to make decisions, right? So search engine poisoning was very, very popular about 6 months ago for us, and we're seeing it spread to other platforms outside of cryptocurrency, where attackers are using public wiki or support platforms where they can put their content on trusted domains, and using that to steal the first page or so of search results for critical applications. So if you're trying to make a decision, how do I get in contact with this company? How do I do this thing, right? You're going to Google it. You're going to Google Microsoft support or Coinbase support or whatever. And if that whole first page is essentially scam results, our view is that even though they look scammy, users will still click on it, and users will still use that information because they trust Google so much. Right? It's that interesting sort of transitive trust application there, where trust shouldn't be transitive in this context. And then these are two more that are very, very similar to that. Answer box pollution and Google Maps locations pollution. So answer box pollution is interesting. So the answer box is this thing. If you've not seen Google's answer box, right? If you ask Google a question and Google thinks it knows the exact answer, it will pop up that a box right there and give you that exact answer below the ads because it doesn't want to make money, but above everything else, right? The way they get this is by mining well-structured pages like this one. This is actually an attacker-controlled page. But they mine well-structured pages where they think it seems authoritative, and they can pull out little bits of information like this to present to the user. So we have seen more and more attackers building pages like this, totally non-malicious, mostly copy, stolen from our website. The only change tends to be the phone number that they present, which I don't know if you can see. You certainly can't see, but it's in there. It's everything else is legit on that page. No phishing, no scam, nothing. Just one wrong phone number. Right? You get enough of those that Google indexes, and Google will change this. Right? That is a particularly insidious attack. Google Maps locations, which I just realized probably only 10 of you can see, because it's all the way at the bottom. Google Maps locations is another interesting thing here. So when you search on Google again, and Google thinks you're searching for a physical place, it will pop up location results below the ads and below, I think, the first three search results. They'll include a box of location results, right? If I search for, I don't know, Emirates Towers, right? Google will pop up a location box there that says, oh, I think you mean Emirates Towers, and this is where it is. What we've seen is attackers creating fake places in Google Maps in order to pollute that set of results. Again, taking advantage of users' trust in Google to pollute the information they're using to make decisions, right? This is almost everywhere we see attackers innovating right now is that ability to pollute that information. This is also super hard to detect for platforms because Google will only show this to you if it thinks it's somewhere near where you are, right? So we had to build a bunch of infrastructure to lie to Google a bunch and pretend we're all over the world and run searches for terms we care about in order to detect these and report them and get them taken down. But most platforms aren't doing that, and this is a particularly dangerous thing for users. A couple other things. I don't think any of these are that. I'll touch on them very, very quickly, and then I think I'll have about 5 or 10 minutes for questions. None of this stuff is that interesting. The one shocking thing I'll point out is that you see this SMS phishing message over here, which we've seen huge campaigns of, and when I look at this, I think, why in the world would I click that link? That doesn't make any sense to me. But users click it consistently. Even users who don't have Coinbase accounts will click that link on a pretty regular basis. And what it boils down to is some amount of going back to that sort of users will do their best to get scammed or phished or compromised, right? They're seeing, oh, I know what Bitcoin is. I want 7 Bitcoin. So great. Let me click that and see what I have to do. We see that extremely, extremely commonly. The other thing we see is attackers